Big Data and Hadoop. Hello, welcome to the module on Big Data and Hadoop. By the end of this module, you will be able to describe Hadoop, its uses, features, and modes of development. Describe Hadoop 1.0 and Hadoop 2.0. Describe HDFS, its architecture, features, and components. Explain MapReduce. Explain the framework of MapReduce. Discuss the data flow of MapReduce. And explain how to develop a MapReduce application. What is Hadoop? Hadoop is an open-source framework used for solving big data-related issues in a distributed computing environment. It is sponsored by the Apache Software Foundation. Hadoop is based on the Java programming language. It uses the MapReduce programming model for its functioning. Hadoop is used for text mining or searching, log processing, data archiving, creation and analysis of graphs, recommendation systems, data warehousing, risk assessment, making predictions, recognizing patterns, sentiment analysis, and business intelligence. History of Hadoop. Hadoop was created by Doug Cutting and Mike Caffarella. It was named after Doug Cutting's son's toy elephant. August 2002, the development of the Notch project started. February 2003, first MapReduce library was built by Google. October 2003, publication of the Google File System paper. December 2004, publication of the Google MapReduce paper. July 2007, a new MapReduce implementation was being used by Notch. February 2006, Hadoop code moved from Notch into the Lucene sub-project. November 2006, publication of the Google Big Table paper. February 2007, Mike Caffarella drove the first HBase code. April 2007, Yahoo was being used by Hadoop for a cluster of 1,000 nodes. January 2008, an Apache top-level project was created by Hadoop. July 2008, terabyte data store benchmark was broken by Hadoop. November 2008, Hadoop 0.19 was released. December 2011, Hadoop 1.0 was released. October 2012, Hadoop 2.0 was released. October 2013, Hadoop 2.2.0 was released. October 2014, Hadoop 2.6.0 was released. October 2016, Hadoop 2.6.5 was released. November 2017, Hadoop 2.9.0 was released. December 2017, Hadoop 3.0.0 was released. Features of Hadoop. Hadoop has many features that make it a popular framework for big data. The features of Hadoop are flexible data processing, structured or unstructured, formatted or unformatted, encoded or plain text, scalable. Nodes can easily be added by Hadoop to support the needs of the system. Fault tolerance. If one system breaks, the copies of the data stored on two other systems can be used. Cost-effective. Uses the concept of parallel computing for commodity servers. Modes of development. There are three models of development of Apache Hadoop: standalone, simple analysis, or debugging is done in this model. Pseudo-distributed simulation of multi-node installation on a single node is enabled in this mode. Distributed large clusters with multiple worker nodes are formed in this mode. Reasons for adopting Hadoop. The reasons for the acclamation received by Hadoop over the years are low cost. The cost of per terabyte of data storage with Hadoop is less as compared to traditional systems. Open source. Open source community guarantees long-term relevance. Scale-out facility. New data nodes can be added to support data growth. Easy integration with traditional tools such as data integration tools, business analysis tools, and statistical analysis tools. Flexible. Hadoop provides the flexibility of storing data in any format and running any kind of algorithm over the stored data. What is Hadoop 1.0 and Hadoop 2.0? Hadoop has two major versions, Hadoop 1.0 and Hadoop 2.0. Hadoop 1.0 supports MapReduce-based operation and Hadoop 2.0 supports Yarn-based operation. The difference between Hadoop 1.0 and Hadoop 2.0: in Hadoop 1.0, scalability is limited by a name node's capacity to load in RAM. Job tracker performs the execution. One name node. Only the MapReduce framework jobs can be run by the user. And Hadoop 2.0 is highly scalable. Global resource manager performs the execution. Two name nodes. Non-MapReduce big data applications can be run on Hadoop. Components of Hadoop. The main components of Hadoop are Hadoop Common, Hadoop Distributed File System, MapReduce, yet another resource navigator. Other components are Pig, Hive, Scoop, Flume, HBase, Uzi, Zookeeper, Mahaudan, Ambry. Hadoop 3. The latest version of Hadoop is 3.0. Minimum version of Java required is Java 8. Physical disk usage is 1.4x. Scalability and reliability have been improved. Shell script bugs fixed and new features included. Map output collector implemented. 2 or more than 2 name nodes supported. What is HDFS? HDFS stands for Hadoop Distributed File System. It allows the user to storage, manage, and index large data resources using the concepts of parallel and distributed computing. Hadoop is a network of machines to store data resources across multiple physical devices. It provides fault tolerance and efficient backup management of the data resources. Hadoop also provides cost-efficient and optimized solution for handling big data resources. HDFS architecture. There are two key components in HDFS: name node and data node. There is a single name node but multiple data nodes. Data nodes are further divided into smaller blocks of memory to store data. Distributed cluster follows master-slave approach. Master maintains the metadata. Features. Key issues of HDFS. The features of HDFS are use of commodity hardware for Hadoop's distributed mode, backup facility by the replicas of original data. Scalability allows new node to be connected. Use of write-once approach to perform the required analytical task. Large storage capabilities, petabytes. The key issues in HDFS. A lot of storage will be wasted if files excessively smaller than the size of the blocks are stored in the data nodes. The data access time in an HDFS system is slow. Components of HDFS architecture. name node and data node. There are two main components of HDFS. The difference between them are name node acts as the central controlling unit, acts as a master for master-slave configuration, maintains the metadata, configured using the RAM or the primary memory. Its failure can be disastrous. Data node acts as the physical storage unit, acts as the slave in master-slave configuration, updates the name node about storage, configured by the secondary memory or the hard disk. Its failure does not affect other nodes. Blocks. Blocks are the small memory segments in a data node. HDFS use blocks to store data files. Size of each block is 128 megabytes. Data files are further split into subfiles of 128 megabytes each. Each subfile is assigned a unique memory. One file's data blocks can be distributed across the network. Distribution is controlled with the help of Hadoop application. Caching. A cache memory helps in reducing the overhead caused by repetitive requests to data node for same memory block. A cache mapping table is maintained by name node to store the information regarding the required data resources. Job schedulers and process managers use cache memory to reduce the file access latency and optimize the task performance of the cluster. System users control a set of cache addresses for data nodes. Replicas. Replicas are the copies of the data sources across the data nodes. The number of copies depends on the configuration of the Hadoop application. Name node creates and controls replicas in the Hadoop application. Data node generates a block report and shares it with name nodes. The block report contains the number of blocks and copies stored by the data node. What is MapReduce? It is a framework for Hadoop. MapReduce is used to write an application which processes huge data in parallel on huge clusters of commodity hardware. It is fault-tolerant and highly consistent. MapReduce works on key-value pairs. Examples of MapReduce keys are distributed index, distributed sort, web-link graph, traversal, and machine learning. Features of MapReduce. The features of MapReduce are: provides the abstraction to the developer from the complication of distributed programming languages, provides a framework for MapReduce execution. Processing clusters failure is expected and also tolerable to fulfill the needs. Availability of inbuilt redundancy. Programming model system of MapReduce is language independent. In charge are the automatic parallelism and distribution. Allows data processing at a local level. Inter-process communication management. The distributed servers which are running different tasks are managed parallelly. Communications and data transfers are managed between the different parts of the system module. Provides failure management systems and redundancy for managing the overall process. Companies using MapReduce. The various companies use MapReduce, and the top companies that are using MapReduce are Google, Yahoo, Facebook, and Amazon. Also tell them the purpose of the companies behind using MapReduce. Google uses to create indexes for Google search, group articles for Google News, and statistically translated machines. Yahoo uses it to create indexes for Yahoo search and identify spam for Yahoo Mail. Facebook uses it for data mining, ads optimization, and spam identification. Amazon uses it for machines which are statistically translating and grouping of products. Lifecycle of MapReduce. The steps in Lifecycle of MapReduce are: first, input and output conditions of the MapReduce jobs are validated. Next, the input splits for the MapReduce jobs are computed. Then, the required accounting information for the distributed cache of the MapReduce job on HDFS is initialized. Then, the MapReduce job jars and configurations associated with it are copied. Then, the MapReduce job are submitted. Lastly, the progress of these jobs is monitored and reported to the job tracker. What is the framework for MapReduce? The two phases of MapReduce are: Map phase. It receives the input from HDFS in the form of key-value pairs. Map function transforms input into another set of key-value pair. This transformed data is called an intermediate set of key-value pairs. Reduce phase. The intermediate form is sorted, divided, and sent to the reduce function. This phase produces the final output. It can be further divided into shuffle. It uses HTTP to retrieve a related partition of this output of all the mappers. Sort. It sorts and groups the input. Reduce. It is a function that calls reduce method to generate output. MapReduce Framework. There are two types of MapReduce frameworks. MapReduce 1. The components of MR1 are single job tracker and multiple task tracker. YON. The components of MR2 are resource manager, node manager, and application master. MR2 has several advantages over MR1, such as better scalability, better resource utilization, and etc. What is MapReduce data flow? Data flow of MapReduce is as follows. A single block of data is processed by one mapper in one instance. The output from the mapper is stored in the local disk. The output from the mapper is sent to the reducer node. Once the task of the mapper is completed, their outputs are shuffled on the reducer nodes. The output from the reducer is final and is written on HDFS. How to write a MapReduce application? MapReduce application must have three parts: the mapper, the reducer, and the driver. The mapper class should contain independent steps. The reducer class should contain the aggregation of the output. The driver class should contain parameters required for a MapReduce job to run. Basic MapReduce logic. The basic MapReduce logic has the following three steps. First, input is split into chunks. Second, parallel processing of each chunk is done independently. Third, results are consolidated in the end. Module summary. This concludes the Big Data and Hadoop module. Let's take a few minutes to summarize the key points of this module. Hadoop is an open-source framework used for solving big data-related issues in a distributed computing environment. It was created by Do Cutting and Mike Caffarella. Hadoop has two major versions, Hadoop 1.0 and Hadoop 2.0. Hadoop 3 is the latest version of Hadoop. HDFS allows the user to store, manage, and index large data resources. MapReduce is a framework of Hadoop that is used to write applications. Google and Yahoo are some of the big companies that use MapReduce for various purposes. I will pause for a few seconds to allow you to read it. Thank you.